This is a kinesthetic model to help participants understand that all the information we obtain about objects in the universe is carried to us by light, and that it takes time for light to travel to us from those objects. The farther away they are, the longer it takes. This activity uses 7 people, 1 to represent Earth, which is receiving all the information, 3 to represent other objects in the solar system, and 3 to represent rays of light coming from those objects. To set up this activity, all of the objects stand in a straight line, starting with Earth. For this demonstration, we will not worry about orbits and the Sun being at the center of the solar system, but only represent the distances between the objects and Earth. The Sun should be 8 steps away from Earth, Mars should be 12 steps away from Earth, and Jupiter should be 35 steps away from Earth. For the next step, the light rays should stand with their respective objects as the messengers that will carry information, and the Earth should turn his back to the entire line. Now the person representing the Sun should perform an action, such as waving her hands. The Sun's light ray then carries information about that action to Earth and tells him about the Sun's action, so that Earth now knows what the Sun was doing. However, after the light ray leaves, the Sun stops waving her hands and performs another action, such as patting her head. But the light ray has already left the Sun, and so Earth will not know anything about this new action unless a new light ray leaves the Sun and comes to Earth with this new information. These same steps are repeated with both Mars and Jupiter. Each time, the light ray takes longer to reach Earth as the objects are farther away, and each time the only information Earth is able to learn is carried by that light ray. In order to learn about the new actions carried out by the objects, another light ray would have to bring that information to Earth. It is important to note that, in reality, the light rays in this activity might actually be generated by the object, like with the Sun, or they might be reflected from somewhere else, like with the planets. The only relevant thing for our model is where they are coming from most recently, not where they originated, so we keep it simple.